we're going to look at twist measurement. This is the icon to measure twist. Twist is a combination of straightness measurement and the relationship radially of a second slide. The straightness can be measured either with keyboard entry, using an ultra-autocollimator or a tally-vel. But the radial measurements can only be either input by keyboard or using a tally-vel. There's two methods of measuring it. You can measure it as a straightness measurement and then a radial measurement. And if you have one tally-vel, you can do both of these as separate measurements. If you have two tally-vels, or a tally-vel and an ultra-autocollimator, we can measure them simultaneously. We'll have one going this way, but at the same time measuring the radial relationship of the second slide. Let's go and look at a measurement example. Here we can use the units imperial metric, and we choose the data source for the straightness measurement and the data source for the twist measurement. I don't have an instrument attached, so the demonstration will be using keyboard entry, but for the straightness we can have keyboard entry, tally-vel 6 data, or ultra-autocollimator data. But for the twist data source, this can only either be a keyboard entry or tally-vel 6 data. As per all straightness measurements, we use a step size, and we can choose this in whichever units we have selected. And then we have an additional twist base length, which defines effectively the distance between the rails. And a tally-vel 6 would normally be attached to this. There are two measurement methods. You can either do two separate measurements for straightness and then twist, and then combine them. Or we can measure them simultaneously. For the first example, I'm going to show them as individual measurements. So when we go through to measure, we're in the straightness measurement mode. So I will simulate some data. And then we can say, okay, we've finished the straightness measurement. I'm now ready to go back to the same positions to measure the radial position between the two straightness datums. I can now put in the radial data. You'll see at the bottom this is still greyed out, which means we don't have enough equal data between the straightness measurements and the radial data. If we now measure the last point, we now have equal numbers, so we can now analyse the data. This is the most important chart. It's the ribbon, the relationship between the straightness measurement we made and then the twist between the second rail at each of those straightness positions. We can go back and look at those as individual charts. This is the straightness measurement in blue. This is the radial twist angle. Or we can go back to the data and see the actual measured data and the equivalent heights because we know each of the base lengths. The same as other calculations, we can edit this data if we feel it's wrong, or we can choose to have different least squares line, end zero line, or minimum zone. If we go back, first of all it will say, are you sure? Because it will discard the results. I can now say, let's do a simultaneous measurement. So I'm just going to do one set of data measuring the straightness and the twist at the same time. It asks us now what type of bridge we have. And if we go into the help page, that'll show you that it's either central to the straightness measurement or offset to the left or right of the straightness measurement. And this is the relationship of that twist to the straightness measurements. For this demonstration, I'll choose it that it's central. Now when we go in, we have two sets of data, and we can measure the y-axis and the radial at the same time. And this would normally be done with the instruments automatically measuring the data. But this time, we can stop at any time. I'll just do one more. We can see we now have equal number of straightness and radial measurements, and we can go through and look at the data, look at the profile chart, and look at the ribbon. The data is exactly the same, but the measurement data logging is different. If we go back, we can always bring in an example from existing results. We can go into Twist, look at our demo data, and we can show a simulation of some data we've already put in for demonstration purposes.